Okay, so we have that compound interest formula, solve for P, the present value, instead of A, the future value. So the question then becomes, how do we put that into our calculator when you have P equals A all over 1 plus R over N to the NT? So what I did was I took my calculator and I did a screenshot of every button that you need to push. This is the buttons that you'll push in the order that you're going to push them to get the correct answer in your TI 36 or 30XS calculator. Make sure you mark this down because you'll be using these keystrokes on every single one of the problems. So let's look at example 7 here. It says how much money should be invested in an account that earns 8% interest compounded quarterly in order to have $30,000 in 5 years. So there's a couple of things that I want to notice when I'm reading this. Here it earns 8% interest, that's R equals 0.08. That's nice and easy. Compounded quarterly, so I do know it's compound interest, not simple interest, so this is N equals 4. In order to have $30,000, so it's I don't have $30,000, it's I want $30,000, so this is actually my future amount now. And then T here is 5 years. So I am going to use the compound simple interest formula, but solve for P instead of A. So that's P equals A all over, in parentheses, 1 plus R over N, close the parentheses, raised to the NT. Now I'm going to plug in the numbers for this particular problem. I'm going to have P equals A, which was $30,000, the amount that I want in the future, all divided by 1 plus R, which was 0.08, the 8% interest, divided by N, which was 4 from quarterly. 4 times T was 5 because I need that money in 5 years. Go ahead and plug that into your calculators now, and let's see what you get. Seems to me, after plugging it into my calculator, I'm getting $20,189.14. Again, that's $20,189.14 is what I'm getting. Now let's think about, does this make sense? This one's really, really important. It's saying, how much do I need to put in an account now if 5 years from now I want $30,000? Had you used the wrong formula, this is not what you would do if you want the right answer, I guess that is. But some students would have just used the A equals P times 1 plus R over N to the NT, and they would have gotten an answer, whatever that answer would have been more than $30,000. And so what that would have been saying is, had you used the wrong formula, you would have said you need to put more than $30,000 in an account today to have $30,000 in an account 5 years from now. That doesn't make any sense whatsoever, so I would have known that's wrong. So when I look at my answer, is it realistic to put $20,000 in an account today, which is less than the $30,000, and I would have $30,000 in 5 years? Yes, that is realistic. It does make sense. I think I'm good on this problem. Again, on this problem, I showed you exactly what the screenshot of the calculator should look like and every button you should push. So let's move on to example 8. How much money should be invested in an account that earns 9% interest compounded semi-annually in order to have $20,000 in 5 years? Let's just start going through the numbers. First number I see is 9%. That tells me R is 0.09. Compounded semi-annually, it's compound interest, not simple, and I know that N is equal to 2. In order to have $20,000, so I don't have it, I want that, so that's my future amount A, and then my time here is 5. Again, I'm going to be using the formula P equals A all over 1 plus R over N raised to the NT. I plug in my values and I'd have P equals 20,000 divided by 1 plus R, which was 0.09, divided by N, which was 2, raised to the 2 times 5. Plug that into your calculator very carefully using the steps that we used in the previous problem. When I plug this in, I'm getting $12,878.55.